All right, we're going to do some basic percent of change problems, and we're going to focus on percent decrease problems. Okay, so numbers are going down, different quantities. So percent of change is of a quantity. The percent of change of a quantity is the extent to which that quantity has increased or decreased, and we're going to be looking at decreases expressed as a percentage. So a number out of 100. So looking at the first example, I used to have 48 pet gibbons, but now I only have 12. So you know that number has gone down by 36 gibbons, right? But I want to know, what does that decrease of 36 gibbons mean as a percentage, right? And it's a good way to compare decreases. You know, if I lose, if I eat 2 apples, but I had, a billion apples, that's a very tiny, tiny, tiny percent decrease. But if I have 3 oranges and I eat 2 of the oranges, I've eaten most of my oranges, so that's a major, major percent decrease. So it's a way of comparing different increases and decreases kind of on the same scale. So, all right, so let's just go through this. So the basic idea of what you're doing is you're looking at the change in quantity, and change is symbolized with a delta. It's like this little triangle looking thing. It's a Greek letter. So the change, the amount of change over the original quantity. That's what's happening. And these are going to be decrease problems. So this change on top is going to be negative. It's going to be a negative number, right? So I used to have 48 pet gibbons, but now I only have 12. So what's my change? My change is it's gone down by 36. And I could calculate that. I mean, you could start with the number you have now minus the original number. And here's the real kind of setup. What you have now minus what you used to have over over what you used to have over the original. Um, but just think about this logically. If I had 48, wait, this was wrong. This should be what I have now minus what I used to have over what I used to have. That's what it is. I'm thinking about too many things at once. But you can just think about it. What's the change here? If I had started with 48 and now I only have 12, I've gone down by 36, so minus 36. Okay, over the original, how many did I used to have? 48. Okay. So first I'm going to turn that into a decimal. So negative 36 divided by 48, and do it on the calculator, do it by hand, whatever. So that's going to be negative 0.75 would be the decimal equivalent of this fraction. Now, to turn it into a percentage, I just move the decimal over 2 to the right. So negative 75%. Okay, and you're multiplying by 100. So the decimal equivalent is 0.75. That's 75 hundredths. So to say what it is out of 100, you multiply by 100. So 75%. It'll be negative 75%. So negative. All right, and here's a little bit of a clarification. This negative 75% would be just my percent of change. Percent of change. Okay. The question is actually by what percent has my quantity of pet gibbons decreased? So the decreased is this negative is sort of included in the question. So the real answer to the question would be just 75%. Does that make sense? So I'd say my quantity of pet gibbons has decreased by 75%. If the question is, what is the percent of change of your pet gibbons, meaning I don't know if it went up or if it went down, then I need to say whether it went up or down by the sign of the percent. So uh, the percent of change was negative 75%, and that tells me it decreased by 75%. If I'm asking by what it decreased, I'm already assuming, I already know that it decreased. So what I just say the percentage. It decreased by 75%. Does that make sense? Okay. So the number of so I'll kind of show that with the next two problems. It's just a word thing, semantics. So the number of cupcakes has decreased from 15 to 10. Okay. So what's my change? By how much has my number of cupcakes changed? Well, it started at 15 and went down to 10. So it's a decrease of 5. I could also look at it as what's my number now? What did my number used to be? So what I have now minus what it used to be, which is negative 5. Okay? Okay, so the change over the original. What's the original? 15. It decreased from 15 to 10. So the amount of change over the original. So let's turn that into a decimal. So that would be equivalent to negative 1/3, which would be negative 0.33 repeating. And then to turn that into a percentage, move the decimal to the right. So that'd be the percent of change would be roughly negative 33%. Or if I wanted to answer it as a percent decrease, I would say my number of cupcakes has gone down or has decreased by 33%. So if the question is neutral, I don't know if it's increase or decrease, I would say that the change is it changed by negative 33%. If I want to say it's decreased, I would say the number of cupcakes has decreased by 33%. All right, last one. Then you're home free. The temperature has gone down by 15 degrees since this afternoon. So what's the change? Negative 15 degrees. Since this afternoon. This afternoon it was 35 degrees. So it used to be 35 degrees. But it went down by 15 degrees. So what is that percent of change? So let's turn that into the decimal equivalent. So 15. Oops. I want to do negative. Well, I'll just make the answer negative. So 15 divided by 35 is 0.42 and something. 0.428. Let's round it to 0.43. So negative 0.43. And then so the percent of change would be negative, roughly negative 43%. Or I could say the temperature decreased by 43%. So that's percent of change, basic kind of decrease problems.